Compiled languages are faster than interpreted languages. Interpreted languages have better developer experience than compiled languages. This is some of the stuff that I'm hearing online. Let's actually break it down and talk about the difference between a compiled language and an interpreted language. When we write code, we write it in a human readable format, right? Typically in a file, in the case of Go, a .go file, right? Maybe main.go. And this file is going to contain human readable text, right? Go code that we as developers work on. The thing is, your computer's hardware doesn't know what any of that human readable text means. Your computer's CPU only understands binary, right? Which is ones and zeros, right? Which at the end of the day is just numbers, right? But it's just numbers and simple operations, things like add and subtract. So we need some process that we can use to convert human readable code to machine code that can be executed by the computer's hardware. And that's all that compilation is. Compilation is just the process of taking some human readable code, right? Go code in our instance, and converting it to binary or machine code that our computer can actually understand. So what does this process actually look like? Well, normally you'd start by writing your Go program. So say main.go. And you'd run it through the Go compiler. On your command line, you'd type go build. And that would produce a new file, which is the executable program. Let's say we were doing a hello world program. It might be hello world.exe. Right? An executable program on your computer. And then you could run that executable directly on your operating system without ever having to use the Go toolchain again. So the great thing is you can take this hello world.exe program and give it to someone else, and they can run it on their computer without ever having to install the Go toolchain or even know that you used Go to build the program in the first place. This is different than languages like Python, where if you want to run someone's Python code, you have to use the Python interpreter every single time, and you run the source code directly on your machine. It's also worth pointing out that part of the reason that compiling is so much faster at runtime is that we do all of this compiling work up front. So when we go to run the executable, we don't have to do any conversions from human readable text to binary machine code. That's different than how interpreted languages work. With an interpreted language, as we run the program, the interpreter is reading the human code and kind of at runtime converting it to machine code that the CPU can operate on. Not to beat a dead horse, but I want to talk a little bit more about execution speed. So we talked about how Go is generally faster than the interpreted languages, right? Python, JavaScript, Ruby, PHP, and so on. It gets a little interesting when we compare Go to kind of the natively compiled languages or the languages that compile directly to kind of machine code that runs on your CPU versus the compiled languages that run on top of a virtual machine, right? So the two big ones that run on a virtual machine are Java and C#, while some of the compiled or natively compiled languages that you'll be familiar with might be Rust, C, C++. Even though Go is a natively compiled language, a language that compiles directly to machine code like Rust, C, and C++, its execution speed is actually more similar to Java and C# when it comes to its runtime speed, how many computations it can do kind of per second. And we'll talk more about this later, but the primary reason for that is the Go runtime. There's basically a chunk of code that's included in every Go program that manages memory, and that tends to slow down the execution speed a little bit. That said, it is worth pointing out that a Go program tends to use much less memory than Java and C# because there isn't a need for an entire virtual machine.